what is an open model?
Yeah, so when people talk about open model, what they mostly mean is open weights. So what that practically means is that any other provider could take the weights of the model and run it directly on another company's hardware. Unlike, for example, OpenAI model or Anthropic models, another provider, another GPU cloud, for example, could take these weights and then provide them somewhere else. And what that means is that if, for example, if it's a Chinese model, but a company doesn't want to use it for privacy reasons, they actually don't need to worry where it came from because it could be run on their own service. So it provides that extra layer of flexibility and you're no longer reliant on that particular provider.
Besides open weight, are there other categories of open models?
Yeah, so the reason why there is debate around the open weight versus open source is that open source traditionally implies that you can completely recreate a bit of software yourself. And the level of openness has been quite limited from that dimension in terms of ability to recreate. And we've seen very few models that are completely open source in a more kind of expansive way. So for that, we need to have the data freely available, we need to have the training code, the inference code, all of these things available. And quite often, if you look at the details of what actually is being made available, quite often it's much more limited. So it could be that we just get the weights and the inference code and nothing really else, and there might be a paper accompanying it. But we don't have the data, we don't have the training code, we don't have 100 other things that actually make you able to recreate it yourself. So hence there is a bit of a limitation versus more traditional open source software that actually applies in practice to open weight models.
Do we have any open source models?
Yeah, so Olmo 3 is one example of a more open model, and there's definitely shades of gray in terms of how open it is, but they certainly made a lot of effort into providing much more information, much more data around what it actually takes to recreate it. So that's a good example, but we have had examples before, actually probably not for a while, of completely open models where you could recreate it yourself. I think it will be interesting to see if we do get a bit of a trend going of completely open models. There was one example by Andrej Karpathy, who's created the Nano Chat. That is probably, at least what comes to mind, the most open one, where he completely talks you through how you can actually create your own tiny ChatGPT yourself, including getting the data, training it, post-training it, just making it available. So that is probably the most open example, but what you get out of it doesn't compare to what are the leading open weight models. So it's quite fuzzy in terms of what is actually open source, open weight, and all the gradations of that.
What are the most well-known open weight models?
So if you look back at the history of it, or very recent history, we saw that Meta was one of the leading companies with Llama 1, 2, and 3, and then I guess they started releasing 4, but that didn't go too well. And then we also had Mistral, which their biggest model was 7B model that really made a splash and really opened up this space. And then since then we had quite a few Chinese models really come into play. Quan 3 was really great. Many series of models of all kinds of different sizes, thinking, non-thinking, dance or MOE models as well. That was really interesting to see that there's such a big spread of models from them. DeepSeek made a splash a year ago where we saw lots of headlines from everywhere and some reductions in the share price for Nvidia and other companies. Yeah, since then we also had new challenges such as GLM models. Kimi K2 was a big model as well. A few different models this year. Minimax, then Longcat models as well. So there's quite a few models, different labs that are coming out of China that are really challenging this space and keeping it very interesting. I would say big labs were releasing a few interesting models as well. So Google was releasing Gemma models that are specifically aimed at the small end. So they had 3B models, I think maybe 8B models, that kind of size. And also I think their biggest one was something like 27B, which kind of performed well enough for that size. But yeah, it would be interesting to see how that develops. And a few months ago we had also OpenAI release 20B model, which performed well for its small size, and then also 120B model. So there's a lot of dynamism in the space, but I would say that Google and OpenAI, while they have released models, I don't think they have in the last few months. They're starting to fall behind in that space. So I would say the key thing to look out for is, are they going to keep it up, or was it a kind of a one-off-ish release to just show a little bit of movement in that space? But competition is very high, so we'll see whether US labs will keep releasing or not. When we get models such as 2 billion parameters or 3 billion parameters, maybe up to maybe 7-8 billion parameters, depending on a few other factors, it is possible to actually run them on quite small hardware, such as on your phone. So we are already starting to see Google with their Pixel phones, they're actually putting the models directly on the phone. Yeah, we saw the same from Apple as well, on the phone, on device. So that's starting to become much more popular. How much value you'll get out of these models, I think, is still yet to be seen, because the argument could also be that as long as you've got internet connection, you could potentially access the bigger models and they could run fast and produce better results. It doesn't mean that, oh, if you can get a model on your phone, that means you don't need anything else and you can just run it on your phone and that is it, because there's still quite a lot of value to access the bigger models. So we saw that Apple, that was maybe 18 months ago when they originally released their plans in that space, they had this hybrid idea where they would have a small model with a lot of LoRa adapters that would be on your phone that can do specific tasks that would directly run locally, and then they will hand off bigger tasks to the cloud models that will be bigger, and also to ChatGPT OpenAI models that would do even more complicated tasks. It's not completely worked out how the smaller models would interact with the bigger models. I think that's all still to be worked out, exactly how that's going to work.
So for the Apple and the Google plans to run at least some locally in a hybrid way, is that for redundancy? Is that for latency? Why would they want to do that?
So there are a few advantages, and by the way, I should say that these models don't have to be open source. I think Google have open sourced some variants of that, but I don't think Apple has, nor it's completely obvious that going forward Google would want to or would need to open source models that they run on the phone. So that's not necessarily one and the same, but it could be connected. One big advantage of the smaller models is that they would run on the user's device, so the inference cost falls onto the device. In Apple's case, for example, they would prefer that because they don't have these massive clusters at the same scale as companies like OpenAI or Google would. So they would prefer to have these smaller models that would actually just run on the hundreds of millions of devices that they sell. That would make sense within their perspective, and then they can also upsell the hardware, tell you to buy iPhone with more RAM, with more GPU power, so you can run better models. So that would be one advantage. There are also potential privacy advantages. There could be some latency advantages in the fact that they can just work offline. And there is an argument to be made that for some use cases where you know exactly what needs to happen and it's pretty constrained, then there's no need for you to keep sending the data to the cloud model and send it back and so on. So there are definitely some advantages, but I would still say that it's pretty early how the space is developing. So we just need to see how good the small models get and where the industry is going to balance out. There are some other interesting dimensions when we look at the open model. So one very important one is what license it has. So licenses like Apache 2, MIT licenses are very open, so they pretty much allow you to do anything. If there are some licenses that may be permissive or allow you to download the weights, but actually don't allow you to run these models commercially, then that's quite a big problem for businesses, for companies who are actually trying to deploy these models. So that's actually very common with image models. A lot of the image models were trained on maybe data that wasn't quite licensed in the most open and legitimate way, and quite often these models were aimed at more hobbyists, are actually not allowed to be used for commercial purposes. So that makes it quite restrictive in what actually legally companies are allowed to do with these models. Quite often there would be more restrictive licenses, and what that means is that while you and I can go and download the weights and run it, but it would not be legal for us to actually go and deploy and build a feature with them. So that was quite common for that to happen, especially a few years ago when the image model market was developing. We saw some really good capabilities, but they were actually not available for many companies to build features off of. But in the text models, in the more language model space, it's not very common to see these licenses now. The best performing open models tend to be licensed in a quite free way. There are some caveats. We've seen some restrictions. A few years ago, Meta introduced some modified licensing, and we saw that a little bit in some Chinese models as well, where they add a few clauses to, for example, an MIT license, where they say, or if you are a big company with over 100 million users, you need to come and talk to us separately to get the license. So it's not quite completely open, but for most companies, it's pretty open that way.
So people interested in an open model would either be developers and hobbyists, or businesses looking to create their own businesses off of them?
Yeah, I would definitely say it's very popular with startups. Open models give you a lot of flexibility, so it's definitely not just for hobbyists. They give you a lot of flexibility to build features in a much more custom way. So the downside with proprietary models is that you often can't actually modify the weight. So if you want to do something really custom or optimized for a particular use case, maybe sometimes you can fine-tune these models, and the fine-tuned weights live still, for example, with companies like OpenAI, but many startups actually want to take the weights, fine-tune it, optimize the model, maybe make it cheaper, maybe more performant for that particular use case that they care about. So open models really make it much more viable to do things like that. If you go back maybe a couple of years, it was quite viable to run the open models just by yourself, sometimes on your own laptop, on your own kind of home hardware. But it's becoming harder and harder for the best performing models to even be viable to run for any kind of reasonable person, or any even maybe a small startup, because we start getting these 1 trillion parameter models that you need multiple nodes of biggest GPUs to run. So that's actually not trivial to do at all. So what starts to happen is that while the models are open, in practice you still need a very capable cloud provider to actually take these weights, optimize them, run them, set up all of the difficult things that they need to do for inference, so then other companies can start using them. So in practice, even if technically I could download the weights myself now and actually theoretically run it on my hardware, because it's so difficult, because they're so big and they require so much energy and compute to run, in practice very few people actually do that. So they still rely on other clouds to do that.
If I'm a developer and I wanted to get started, what would you recommend? What's a good model to start with, and then what's a good setup?
There is definitely a good market, a good ways to run the models, such as, for example, you can have bits of software such as Llama, where you can then download that software and then they make available a bunch of different open models that are small enough for you to run on the laptop. If it's a completely toy use case to just try things out on your own laptop, then that's quite straightforward to do. Anyone can do that. But there's definitely very big cutoff in terms of what kind of models you can actually run. So smaller models or very quantized models, so maybe the bigger models that have been optimized to run on smaller hardware, you can do that. They could be quite slow to run, but that is possible to run. And if you have a good laptop, you can do it. But the biggest, highest performing models, such as, for example, Kimi K2 or JLM 4.6, these are way too big to run on anyone's laptop, unless they're very, very heavily quantized. But the biggest, the best open source models, typically still you have to go to the provider either the first-party provider who created, the lab who's created these models, or actually just other clouds that would actually deploy these models and run them. There are definitely a few things you can do. One thing, you can just chat to it in the same way like you can to ChatGPT, Gemini. That is a little use case you can do, and especially if you're on a plane flying, you don't have connection, then that's something, you've got a bit of intelligence in your pocket. So that becomes much more viable. But beyond that, you can do more sophisticated things with it, and you can fine-tune your models and customize them and so on, but that requires much more technical skill. But it's certainly something that one can do, and it's great to have these models available in the open, so people like you and I can try them.